Dear viewers, welcome to the SJC e-content media. Myself, Dr. A.Rajesh, Assistant Professor of Mathematics. In this video, I am going to present to you Real Analysis 1, Unit 5, Sequences of Functions. Topic, the Cauchy condition for uniform convergence. Definition of uniform convergence. Let Fn be a sequence of functions which converges pointwise on a set S to a limit function f. This means that for each point x in S and for each epsilon greater 0, there exists on n, depending on both x and epsilon, such that small n greater capital N implies mod fn of x minus f of x less than epsilon. If the same n works equally well for every point in S, the convergence is said to be uniform on S. Definition of converge uniformly. A sequence of functions fn is said to converge uniformly to f on a set S if for every epsilon greater 0 there exists an n depending only on epsilon, such that small n greater capital N implies mod fn of x minus f of x less than epsilon. For every x in S, we denote this symbolically by writing fn converge to f uniformly on S. Theorem. Let fn be a sequence of functions defined on a set S. There exists a function f such that fn converge to f uniformly on S if and only if the following condition, called the Cauchy condition, is satisfied. For every epsilon greater 0, there exists on n such that small m greater capital N and small n greater capital N implies mod f m of x minus fn of x less than epsilon for every x in S. Proof. Assume that fn converge to f uniformly on S, then given epsilon greater 0, we can find n so that small n greater capital N implies mod fn of x minus f of x less than epsilon divided by 2, equation 1 for all x in S. Taking small m greater capital N, we also have mod f m of x minus f of x less than epsilon divided by 2, equation 2 for all x in S. For small m greater capital N and small n greater capital N, mod fm of x minus fn of x equal to mod fm of x minus f of x plus f of x minus fn of x less than or equal to mod fm of x minus f of x plus mod fn of x minus f of x less than or equal to epsilon divided by 2 plus epsilon divided by 2. Therefore, mod fm of x minus fn of x less than epsilon for every x in S. Conversely, suppose the Cauchy condition is satisfied, then for each x in S, the sequence fn of x converges. Let f of x equal to limit n tends to infinity fn of x if x belonging to S. We must show that fn tends to f uniformly on S if epsilon greater 0 is given. We can choose capital N so that small n greater capital N implies mod fn of x minus fn plus k of x less than epsilon divided by 2. Equation 3. For every k equal to 1 comma 2 comma 3 dot dot and every x in S. Therefore, limit k tends to infinity mod fn of x minus fn plus k of x equal to mod limit k tends to infinity fn of x minus limit k tends to infinity fn plus k of x equal to mod fn of x minus f of x less than or equal to epsilon divided by 2. Hence, small n greater capital N implies mod fn of x minus f of x less than epsilon for every x in S. This proves that Fn converges to F uniformly on S. Thank you.